Students, are you able to hear me?
Yes, sir.
Okay. See, I'm stuck in bad traffic here. It is raining also. I'll be reaching in maximum within 10 minutes. That's what I'm expecting. Okay. So I'll come and start. That is what I wanted to inform you guys. I'm driving. I'll just reach in 10 minutes and I'll start. Is it clear? So I'll be starting a new chapter today. Okay. So till then, if you have a textbook, just go through it. System of particles and rotational motion. Clear?
Yes, sir.
Okay. Students, are you able to see me? Students, am I visible and audible? Yeah?
Yes, sir.
Good. I'm sorry for the delay. I didn't expect I got really stuck in a bad traffic. So we'll get started for the, started with the next chapter. So we'll get started with the next chapter, that is system of particles and rotational motion. Right? So as the name of the chapter suggests, yeah. So as the name of the chapter suggests, right? So we are going to have system of,
Sir,
yeah, tell me.
sir, this is Divya, sir. I'm also attending from Catherine's account.
Okay, okay.
Okay, sir.
Okay. So when we talk about the system of particles, right, as the name suggests, you have particles. So basically, what are particles? Particles are point-sized objects. And if you have a system with these point-sized objects, we can call them as system of particles. Right? As simple as that. So if I give you a system of particles, then there are certain parameters that we can try to find which are associated with them. So one among them is called as the center of mass. Right? So as the name suggests here, center of mass means center is a point which is going to define something with respect to a mass. That's what I'm able to understand. Right? So when I take a particle like this, a system of particles like this. Let's say you have a five particle system where there are M1, M2, M3, M4, and M5, something like this. Okay. So all these particles have masses associated with them. But the question here is, I repeat it, but the question here is, if I have to replace this whole system, right? If I have to replace the whole system of all these five particles with one particular particle whose mass, if I call it as M equivalent, meaning I'm replacing the whole system with one mass, which I call it as the value M equivalent, then this M equivalent can be defined in terms of the masses of these particles. I repeat, in terms of the masses of these particles and their positions. Right? So that's what we call it as center of mass. Okay. So now we will give a definition to it. Now, a definition given to the center of mass is something like this. It is a point where the whole mass of the system is said to be
concentrated. So it is a point where the whole mass of the system is said to be concentrated. Right? So am I clear with this? Okay. Now, let me explain this concept. See, let us say there is a block of mass m, which is accelerating with a value a. Then, if I ask you to define what is the force acting on this particle, will you be able to define and tell me? Will you be able to define what is going to be the force acting on it? If a particle of mass m is said to accelerate with a value a, then what is going to be the force acting on it? The external force, according to Newton's second law, is going to be equal to m into a. But we know this fact that m is the mass of the object where it is said to be concentrated at a particular point. So to be very specific, then I will write the external force that is acting on this object is the mass of this object, which is concentrated at its center of mass. And this acceleration, which I'm defining, is actually called as the acceleration of center of mass. Why is it called like that? See, because if I take this block is made up of many number of particles. So when I say acceleration of this block, I'm trying to define the acceleration of which particle, right? So if you ask that question, we are able to understand that the whole mass, when you convert it into a point mass, then you can say that the acceleration you're trying to define is also the acceleration of that particular point, right? Which we call it as the acceleration of center of mass. So how do you read it as? It's called as acceleration of center of mass. So are you able to understand this point? Am I clear? So till now, we didn't say that F is equal to ma means acceleration you're trying to talk about is actually the acceleration of center of mass, right? But I hope it is clear now. Yes or no?
Sir.
Okay. Now listen to this point. Now we are going to define the position of center of mass. So when I say the position of center of mass, I can have different kinds of systems of particles in my hand, right? So the position of center of mass is first defined with respect to, let's say, system of two particles. Second, we can define with a system of large number of particles. And third, we can define it with respect to continuous bodies. So continuous bodies are also called as extended objects. Let me give you an example. So when I say system of two particles, right, I have 2 point masses present in the system. Let's say the 2 point masses are M1 and M2. This is called as system of two particles. Suppose I have a system like this. M1, M2, M3, M4, M5, and M6. This is called as system of large number of particles. And if I take this pen into consideration, this pen is made up of multiple charged particles, multiple particles here. So this pen can be treated as a continuous body, or it can also be treated as an extended object. Is the point clear? So we will start one by one. So first, when I talk about system of two particles, if I take one mass to be here and the other mass to be here, okay. Listen, whenever you're trying to find the center of mass of a particular system, you need to have something called as a reference point. And with respect to this reference point, you have complete freedom. So there is no hard and fast rule saying that this should be the reference point or something else should be the reference point. It is fixed. I mean, it is, you're free to choose it, right? So, for instance, if I take the reference point to be here, reference point is basically the origin. Then if I draw a line like this, so that I'm able to say that M1 and M2 are lying on the x-axis. When that is a scenario, here if I take the position of M1 to be x1, 0, and if I take the position of M2 as x2, 0, then let me say the center of mass is somewhere over here, which I'll call it as xcm, 0. Then x coordinate of the center of mass is given as, listen to this carefully, mass of the particle into its corresponding x coordinate plus mass of the second particle into its corresponding x coordinate divided by m1 plus m2. And this is going to be the x coordinate of the center of mass. Is the point clear? Okay. So this is going to be the x coordinate of the center of mass. Now, if I have system of large number of particles, if I have a system of large number of particles, then if I take those particles to be at position of masses m1, m2, m3, m4, so on till mn, where the position of m1 is x1, y1. The position of m2 is x2, y2. Okay. And the position of m3 is x3, y3. So it keeps on going like this, so that the position of mn is xn, yn. If I take it like this, then I can say that the x coordinate of center of mass of this particular system is going to be equal to, this particular system will be equal to m1 into x1 plus m2 into x2 plus so on till mn into xn, the whole divided by sum of all the masses. Similarly, the y coordinate of center of mass will be equal to m1 y1 plus m2 y2 plus so on till mn yn divided by sum of all the masses. Okay. Oh, okay. 12th class இல்ல 12th சொல்லுங்க. Yeah. Okay. So next is when I have a system of continuous bodies, right, or continuous mass. When I have this kind of a system, what we need to do is listen to this carefully. If I have, for example, a rod, then x coordinate of center of mass can be taken as integral of, listen to this, integral of x into dm divided by the integral of dm. Okay. So I'll tell you how to handle this. So where x is the distance from the reference point, where x is the distance from reference point, dm is the small mass considered, right? So this is how it is going to be. Similarly, y coordinate of center of mass will be integral of y dm divided by the integral of dm, and the z coordinate of center of mass will be equal to integral of z dm divided by integral of dm. Okay. Now, make a note of this. I'm going to teach you how to apply all these concepts. So I'm not sure if you're able to understand or not. None of you are discussing actually. Okay. Listen.
Sir,
Tell me.
sir, what is the z coordinate
Z coordinate
taking place here? So why is there z center of mass?
because the three-dimensional object, it will be Z coordinate also come into picture.
Okay, sir.
Yeah. So now I'll give you a problem. Look at it. If I take the example 1, then write down 4 particles of mass 1 kilogram, 2 kilogram, 3 kilogram, and 4 kilogram are placed at the 4 vertices of a square of side 1 meter. Okay. Find the position of center of mass of the particles. Okay. So listen to this. 1 kilogram, 2 kilogram, 3 kilogram, and 4 kilogram are placed at the vertices of a square. Okay, they are placed at the vertices of a square of side 1 meter. Okay, the side is going to be 1 meter here. Now, we need to find the position of the center of mass of these particles. So for that, what we will do is, we will take this to be the origin. So it is always advisable that you take, when you have multiple system, right? When you have a system of multiple particles, I suggest you take one of the particles position to be origin itself. If that is the case, then what is, if this is O, A, B, C, then what is going to be the coordinate of point A? It is going to be 1, 0. What is going to be the coordinate of point B? So coordinate of point B will be 1, 1. What will be the coordinate of point C? It will be 0, 1. Now, if you see, when I need to calculate the x coordinate of center of mass, if the x coordinate of center of mass is to be calculated, the formula is m1x1 plus m2x2 plus so on till mn xn the whole divided by m1 plus m2 plus so on till mn. Then the x coordinate of center of mass will be equal to m1 is 1 into x1 is 0 plus m2 is 2 into x2 is 1 plus m3 is 3 into x1 is 1 plus m4 is 4 into x1 is 0. The whole divided by sum of all the masses, that is 1 plus 2 plus 3 plus 4. Right. So the answer here will be 2 plus 3, that is 5 divided by 7 plus 10, which is going to be half. Is it clear? So the x coordinate of center of mass is going to be 1 by 2. Okay. Next. The y coordinate of center of mass, it is a similar formula, m1y1 plus m2y2 plus m3y3 plus m4y4, the whole divided by m1 plus m2 plus m3 plus m4. Right. So this will be equal to m1 is 1 into y1 is 0 plus m2 is 2, y2 is 0 plus m3 is 3 and y1 is, sorry, y3 is 1 plus M4 is 4 into Y4 is 1. The whole divided by sum of all the masses, 1 plus 1 plus 2 plus 3 plus 4. So this is going to be equal to 3 plus 4 is 7, 7 divided by 10. So the x coordinate of center of mass, comma y coordinate of center of mass is equal to half, comma 7 by 10. And this will be the required answer. Okay. But this half, comma 7 by 10, when you're reporting this answer, you need to be very cautious with one thing. So 1 by 2, comma 7 by 10, when the 1 kilogram mass is considered to be the origin. When 1 kilogram mass is considered to be the origin. Okay. So is it clear till this step?
So, but wouldn't the same apply for 1 by 2 also? Wouldn't the same condition apply for 1 by 2 also?
The coordinate itself, no, I'm not talking about. See, 1 by 2, comma 7 by 10 is the coordinate with respect to 1 kilogram being considered as the origin. I didn't write it only
Oh,
for
both.
7.
Oh, okay, sir.
Yeah. Let me know once you are done copying it.
Sir,
Yeah, tell me.
sir, for that continuous body's x coordinates, sir, it is integral of x dm by integral of dm. Integral of dm, we can write it as m itself, right?
Yeah, you can write.
Okay,
You can
sir.
write. Mhm. Okay. So if you're done with this, then I'll explain for continuous bodies. Okay, shall I proceed? So see, center of mass for continuous bodies. So what we should do is, let us say we have a rod. Okay. We have a rod of length L and negligible thickness. Now we need to find the center of mass of this rod. So logically speaking, where will the center of a uniform rod be? Obviously at the center. So if I take this to be the reference line, from here, it will be at a distance of L by 2. Right. But we are supposed to prove it. So for that, what we need to do is, there are certain steps to be followed. of which the first step is depending on the object, define the type of mass density. Okay, I'll tell you what that mass density is. Second, consider a reference point or a line. Consider a reference point or a line. Third, so third is from the reference point or line at a distance x, consider a small portion of thickness dx and mass dm. Okay. The next point is define dm in terms of dx. Fifth is apply formula of center of mass and integrate with proper limits. Okay. Now, I'm going to show you how to apply. So, we will find the center of mass of a uniform rod of length L and negligible thickness. So, if I take a rod of length L, right, then the mass density that I can define. So I have to explain you what this mass density is. So you know this density is mass per unit volume, right? This is what you would have learned in your lower grades, right? But this mass per unit volume is actually called as volume density. So the amount of mass per unit volume is called as volume density. Similarly, if we define the length, if you define the mass per unit length, you call it as linear mass density. So basically, when you talk about mass density, right, there are three kinds of mass density. One is linear mass density. Then you have surface mass density. And lastly, you have volume mass density. So linear mass density is defined as the amount of mass per unit length. Surface mass density is defined as the amount of mass per unit area. And volume mass density is defined as the amount of mass per unit volume. Clear? Okay. Now, if you look at the scenario that is given here, since they have given a rod of length L and negligible thickness, it is a one-dimensional object. So for one-dimensional object, the type of mass density that we define is linear mass density. And linear mass density is represented with the symbol lambda. And lambda is equal to m divided by L. And let this be the first step where the mass of this rod is capital M and the length of the rod is capital L. Okay. Second step is consider the reference point or reference line. If I take this to be the reference line, then from the reference line at some random distance x, I am considering a small portion of thickness dx and whose mass is dm. Okay. Now, if you see, the mass of capital M is spread over a length of capital L, then a mass of dm will get spread across a distance of dx. So from this, I can conclude that dm divided by capital M is equal to dx divided by capital L, or dm will be equal to capital M by L into dx. And let me call this as 2. Okay. Okay.
Sir, can you come again?
Which one? This pointer.
Yes, sir.
So if one book or one pen costs 10 rupees, 5 pens will cost how much?
50, sir.
How did you get that 50? If I take this to be x, then x into 1 is equal to 5 into 10. So x will give you 50, no? Same logic. M into dx is equal to L into dm.
Okay, sir.
Got it? Yeah. Now, if you're clear with this, I'll proceed. You're clear? So listen. Now, the x coordinate of center of mass is equal to integral of x dm divided by integral of dm. And I told you need to take it with the proper limits. So this is equal to integral of x is x only, but in the place of dm, what can I write? I can write m by capital L into dx. And what are going to be the limits? If I take the rod again, so with respect to the reference line, if I take this to be the origin, for me to cover from here till the end of the rod, then I need to have the initial point to be 0 and the final point will be at L, because I'm integrating with respect to dx. the whole divided by integral of dm is going to be capital M. So here m by L is a constant that can be taken out of the integral. So m divided by L into integral of x dx between 0 to L, the whole divided by capital M. So m and m will get cancelled, which implies 1 by L into integral of x dx is going to be equal to x square by 2 between 0 to capital L, which implies 1 by L into L square by 2. So this will get cancelled. Answer will be L by 2. So is it clear? Means exactly at the center, you have the center of mass at a distance of L by 2 from the origin or at a distance of L by 2 from the other end. Am I clear with this? Okay. Now, see, generally, this kind of question will not come in your board part. There's mostly needed only for competitive exam. But if at all they ask you, you should be in a position to handle. That is the reason I explained. Like this, when you try to calculate the center of mass of different kinds of objects, right? Then you will get this list. So you can make a note of this. Center of mass of first, a rod is L by 2. Second, of semicircular ring is equal to 2r divided by pi. So it is at a distance of 2r divided by pi from its center. So here L by 2 from any one end. Okay. Third is, if I have a semicircular disk, then it is at a distance of 4r divided by 3 pi from its center. Fourth one, hemispherical shell. So when you talk about the hemispherical shell, it is at a distance of r by 2 from the center. Okay. So if I take a hemispherical shell from the center, it is at a height of r by 2. Okay. Fifth one is, if I have a solid hemisphere, an answer will be 3r divided by 8. This is also from its center. Okay. Now, the next point to be noted is motion of the center of mass. So motion of the center of mass. So what we will do is, let us consider the motion of system of n particles, motion of system of n particles, that is m1, m2, so on till mn, and total mass being capital M. Okay. So capital M, which is a constant, meaning there is no addition or deduction of mass taken place during the object is moving. Then the r coordinate of center of mass in terms of vector, the position vector of the center of mass is going to be equal to mass of the first object into r1 vector plus mass of the second object into r2 vector plus so on till mn rn vector, the whole divided by m1 plus m2 plus so on till mn. Okay. Now, if I differentiate, so before I differentiate, if I take the sum of all the masses to be like this, m1 r1 vector, m2 r2 vector plus so on is undisturbed plus mn rn vector, the whole divided by capital M. This capital M, I'll take it to the other side. So capital M into r coordinate of the center of mass is equal to m1 r1 vector plus m2 r2 vector plus so on till mn rn vector. Now what we will do is differentiate with respect to time on both sides. When you do this, you will get capital M into d by dt of r coordinate of center of mass is equal to m1 into dr1 vector divided by dt plus m2 into dr2 vector divided by dt plus so on till mn into drn vector divided by dt. Okay. Now, if you see, what is the derivative of position vector with respect to time called as?
Velocity vector.
Yes. So here it will be capital M into velocity vector of the center of mass is equal to m1 v1 vector plus m2 v2 vector plus so on till mn vn vector, where if you see m1 v1 vector is the linear momentum of the first particle, m2 v2 vector is the linear momentum of the second particle, so on till mn vn is going to be the linear momentum of the nth particle. Right. Now, having all these things in mind, what we can say is the linear momentum of the center of mass is given as the vector sum of the individual linear momenta. Let me know once you're done. Done. Now the next question.
Sir, can you show the previous slide, sir? Okay, sir.
No. Now, if I differentiate this further with respect to time, then I'll get m into d by dt of velocity of center of mass vector is equal to m1 into d1 dv1 vector divided by dt plus m2 into dv2 vector divided by dt plus so on till mn into dvn vector divided by dt. So capital M into derivative of velocity with respect to time is going to give us acceleration of the center of mass is equal to m1 a1 vector plus m2 a2 vector plus so on till mn an vector. That is why I told you, when you take a block, the block is made up of m number of particles, n number of particles. If you take mass of each particle and multiply it with the acceleration, sum of all those values will give you the total mass of the object and acceleration of center of mass. If you observe, this is what is Newton's second law. Okay. So we can say that the force acting on the center of mass is equal to the vector sum of the individual forces experienced by the particles in the system. Okay. Now see, I'm going to give you a problem. Example. So if I take a pulley and mass system like this, okay, if I take A and B, where mass of A is 2 kilogram and mass of B is going to be equal to 1 kilogram. Okay, and the string is inextensible. What is it? It is inextensible. Now find the acceleration of center of mass of the system. Find the acceleration of center of mass of the system. So to put it in simple terms, you need to find what is the acceleration with which A and B are moving. So how to solve that? So we will go with the free body diagram concept. So MA into G is acting downwards. Tension here is acting upwards. And acceleration is in the downward direction. So MA into G minus T is equal to MA into small a. So let this be equation number 1. Similarly, if I take B into consideration, it will be MB into G, and here it is T, and this will be acceleration. So T minus MB into G is equal to MB into A. let this be second equation. Now you add first and the second equation, you will get MA plus MB into G is equal to, sorry, MA minus MB into G will be equal to MA plus MB into A. So what will be the acceleration? A will be equal to MA minus MB into G divided by MA plus MB. So MA minus MB is going to be equal to 2 minus 1. So 1 into G divided by 2 plus 1 is going to be 3. So answer will be G by 3. Right. So this is the acceleration of the block, right? So I have to do a small correction. So this is the acceleration of block. When you talk about the acceleration of center of mass, what did you get? So when you saw the acceleration of center of mass, right, it came out to be net force acting on the object divided by the total mass. So acceleration of center of mass is net force divided by the total mass. So that will be equal to 1 minute. So listen. So acceleration of the center of mass is net force divided by the total mass. So what is going to be the net force that is acting? MAG is acting downwards, MBG is acting downwards. One tension is acting in the upward direction, the other tension is also acting in the upward direction. So net force will be MA plus MB into G minus 2T, the whole divided by the total mass of the system, that is going to be 3. So MA plus MB into G is how much? That is 3G minus how much is 2T or how much is T in the first place? So since you know the acceleration of block is G by 3, can you find the tension and tell me? So how much is the tension less? So substitute G by 3 here. How much are you going to get the value of tension as? You will get T is equal to 4G divided by 3. So when it is 4G divided by 3, substitute it here. So 3G minus 2 into 4G divided by 3, the whole divided by 3, which is going to be 3G minus 8G by 3 by 3. So 9G minus 8G is G divided by 3 into 3 is going to give us 9. So this G by 9 is going to be the acceleration of center of mass. Okay. So you're done. Now see the alternate method to solve the same problem. So the alternate method is acceleration of center of mass is equal to mass of A into acceleration of A vector plus mass of B into acceleration of B vector divided by the mass of A plus mass of B. Right. So to find the acceleration due to A, we know that acceleration due to A is equal to acceleration due to B is equal to G by 3. We already calculated that. Now, if you see what is going to be the acceleration of center of mass here, it will be mass of first object, that is 2 multiplied with G by 3 plus 1 multiplied with minus G by 3. Why? Because A is going downwards, B is going upwards. The whole divided by 3. So it is going to be 2G by 3 minus G by 3 divided by 3. So it is going to be G by 3 by 3, which is going to be G divided by 9. Okay. So this is how we apply the motion of center of mass. So one last concept for the day is center of mass if some mass or area is removed from a rigid body. Then position of center of mass of the remaining body. So how to calculate it? Suppose I have a circle like this. and from this circle, there is another portion that is removed. Then you will find the r coordinate of center of mass like this. A1 into R1 vector minus A2 into R2 vector, the whole divided by A1 minus A2. So this is going to be the answer. I'll show you how to solve it. Okay. Listen. So there is a circular portion like this. There is an other circular portion like this in such a way that you have this as X, this as Y, and the radius of the bigger circle is considered to be A. So this is the removed portion. Okay. Now you need to find the position of center of mass of this system. So you can take this to be the origin. Now if you see, for bigger circle, where is going to be the center of mass? Center of mass is at its center, which is going to be 0, 0. Okay. Similarly, center of mass for smaller circle is at its center. So if I consider this point to be 0, 0, where is the center of the smaller circle going to be? It will be at a by 2, 0. So which is a by 2, 0. Now, area of bigger circle is pi a square. Area of smaller circle is pi a square divided by 4. Okay. Now, how do I find the r coordinate of center of mass? It is actually going to be along the x-axis. It is obvious. X coordinate of center of mass is going to be a1, that is pi a square into x1, 0, minus pi a square by 4 into a by 2, the whole divided by pi a square minus pi a square divided by 4. So this will be 0. And this will be equal to minus pi a cube divided by 8, the whole divided by 3 pi a square divided by 4. So these two will get cancelled, pi and pi are gone, a square will cancel this. So minus a divided by 6 will be the answer. Means the center of mass will get shifted to the left by a distance of a by 6. So the x coordinate of center of mass will be equal to minus a by 6, 0. So is it clear? So this is all about the center of mass. Is there any doubt that you have? So why is no one responding? Are you guys there?
Yes, sir.
Yes, sir.
Is it clear or is there any doubt?
Well, sir.
So the next class can we discuss about the next part, that is rotational motion.
Okay, sir.
Okay. So that's it from my side. We'll end the session.
Thank you, sir.
Sir, can you show the previous slide? The alternate method slide, sir. Hmm. Thank you, sir.
You're done?
Sir,
Tell me.
sir, in work power energy collisions, that's all, sir.
That's so collision, we were supposed to discuss normally collision.
Yes, sir,
Oh,
you completed only till elastic.
elastic collision. So inelastic part we are supposed to discuss. Okay, I'll do that tomorrow. Please remind me. I was thinking that it's over and I will explain. So tomorrow we'll discuss anyways, the center of mass is an independent topic only. There is nothing like a continuation for the next part of the chapter. So we can stop it and we'll discuss the oblique collision and the inelastic collision tomorrow. Okay.
Okay, sir.
Okay. We'll wind up.
Thank you, sir.
Yeah.